Hello, welcome back to Olympiad problem. Let's see three more algebra problems today. So let's go one by one. The first one, prove that 1234 to the power of 1111 plus 3321 to the power of 1111 is divisible by 511 and 101. So let's see if you see there is a symmetry you can see in the problem. Okay, so it is in the form of a power n plus b power n. So to solve this problem, you should know this one. A power n plus b power n is divisible by a plus b for odd integer value of n. If n is odd, then a power n plus b power n is divisible by a plus b. If you know this, it is very simple. So first, let's derive this theorem. Okay. Let's prove that a power n plus b power n is divisible by a plus b for odd integer values of n. Let's prove this first. It's so simple. Uh, let's call a power n plus b power n as function of n. N is odd integer. Then the remainder of f function of a when f function of a is divided by a plus b is function of minus b. Right? This is the remainder theorem. Okay. So f of minus b, if you find out, then we get the remainder. F of minus b equal to, I have to replace at the place where a is there. Okay, because f of a is function of a. So wherever a is, I am replacing with minus b. So it is minus b to the power of n plus b to the power of n. As n is a odd integer, it is minus b power n plus b power n. Okay, which is equal to 0, which means remainder is 0. That means a plus b is a factor. Okay, so a power n plus b power n is divisible by a plus b for all odd integers of n. Now, since we proved this, it's very easy. The problem is here a is 1234 and b is 4321, n is 1111, right? So this is divisible by 1234 plus 4321, which is nothing but 5555, 5555, okay? Which I can write it as 5 into 11 into 101. So all the three are factors of this expression. Okay, so yeah, next. Since we learned this theorem, let's see complete theorems of a power n plus or minus b power n. So a power n minus b power n, it is always divisible by a minus b, and when n is even, it is also divisible by a plus b. When n is odd, it is not divisible by a plus b. Okay. Same way, a power n plus b power n, it is never divisible by a minus b. Okay. If n is odd, it is divisible by a plus b. When n is even, it is not divisible by a plus b. Okay, so these things, if you remember, you can solve more problems. Okay, next question. Given that positive integers x greater than 1 and y satisfy 2007x minus 21y equal to 1923. Find the minimum value of 2x plus 3y. If you see here, there is only one equation given, and it's a two variable equation, right? Normally, to solve a two variable equation, you require two equations. So now we have to use the properties of numbers here to get to 2x plus 3y. Okay, let's see how to do this. Okay, 2007x minus 21y equal to 1923. You first divide by 3 on both sides. You'll get 669x minus 7y equal to 641. Okay, now I separate x and y terms to both sides, LHS and RHS side. I brought x and y terms, and one side is 669x, and I added minus, I subtracted 669. So other side also 641 plus 7y minus 669. So if I simplify, it will become 669 into x minus 1 equal to 7 into y minus 4. So if you see this expression, we know that x is greater than 1. Okay. So the solution set will be x minus 1 should be multiple of 7 and y minus 4 should be multiple of 669 and k should be the multiple value k which should be same to solve the equation. Okay. So given the condition that x is greater than 1 and x minus 1 is greater than 0. Okay. So it can't be 0. K cannot be 0. Okay. So k equal to 1 if you substitute, what you will get? K equal to 1, x minus 1 equal to 7 and or x equal to 8 and y minus 4 equal to 669 or y equal to 673. And this is the values we should take for minimum value of 2x plus 3y because any other value 2x plus 3y value will increase, right? So 2x plus 3y equal to 2035. This is the answer. Thank you. Next. Okay, the next problem is 4n square minus 5n plus 16 equal to m square. M is a positive integer and n is an integer. N can be negative or positive. M is a positive integer. What is the maximum value of absolute m minus n? Okay, so let's first write it like 4n square minus 5n plus 16 equal to m square. What I'm trying to do is basically we need to get to x square minus y square equal to some number and that number should be a prime. Okay. So I'm just multiplying with the 16 on both sides because m square side I can maintain, still I can maintain a perfect square, 4m whole square. And I try to bring a whole square plus some number on the other side. Okay. So 64n square minus 80n plus 256 equal to 16m square. I can rewrite this as 8n whole square minus 2 into 8n into 5. So that means I should get a 5 square, that is 25 plus 25 plus 231 equal to 4m whole square. Now I can write this as 18 minus 5 whole square plus 231 equal to 4m whole square. Now I take 18 minus 5 whole square to other side, it will become 4m square minus 18 minus 5 whole square equal to 231. This is x square minus 5 square equal to some prime number, right? I can rewrite this as 4m minus 8n plus 5 into 4m plus 8n minus 5 equal to 231. Okay, since 231 is a prime, it is 231 into 1. So we can make two equations 4m minus 8n plus 5 equal to 1 and 4m plus 8n minus 5 equal to 231. These are the possible values for the given m and n as integers, right? So I just choose a bigger number that is 4m plus 8n minus 5 as 231 and smaller one as 1. If you sum up, you will get 8m equal to 232 or m equal to 29. And if you subtract, you will get n equal to 15. That leaves us absolute value of m minus n as 14. Okay. Thank you.